Welcome. Today we're delving into one of the most profound questions in physics. Where do particles actually come from? How can the fundamental building blocks of our reality just appear? Well, according to topological geometrodynamics, the answer isn't some kind of magic, it's found in the very geometry of space-time itself. So, let's dive in and see how this works.
To really get to the bottom of this, we're going to start with the central puzzle, the creation of particles. Then we'll draw on a really key analogy from quantum theory that points us toward a rather strange kind of geometry, something we'll call the V-turn. After we understand the structure of these particles, we'll see how this V-turn provides the solution, and that's going to lead us to a truly stunning conclusion about the nature of our universe.
All right, so let's start with the enigma itself. If the universe is fundamentally a geometric structure, how can a new piece of that structure just pop into existence?
To put it more precisely, how are particle-antiparticle pairs created seemingly from the vacuum? This is a huge challenge for any theory that views particles as stable geometric objects. I mean, a stable structure can't just materialize out of thin air without some kind of mechanism. So, what is that mechanism?
You see, in this framework, a particle isn't just a point. It's this extended object, a pair of what are called wormhole contacts that link two parallel space-time sheets, and there's a conserved magnetic flux that loops right through them. Think of it like a permanent, self-contained geometric circuit. And right there, that's the problem. If it's so stable, so permanent, how can it possibly be created from nothing?
Well, to solve this geometric puzzle, we can actually find a powerful clue in a well-established idea from quantum theory: the creation of particles like electrons and their antiparticles, positrons.
The idea, which goes all the way back to Derek, is really quite ingenious. What we perceive as a particle-antiparticle pair appearing from the vacuum can be looked at in a completely different way. Imagine it's actually just a single particle traveling forward in time, which then suddenly reverses direction and starts traveling into the past. From our perspective, this particle moving backward in time looks exactly like an antiparticle.
Now, this is where the concept of time reversal often gets misunderstood. This is not some gentle, continuous U-turn in time, and it's definitely not a particle simply stopping and retracing its exact same path backward. Both of those interpretations are just plain wrong. They don't capture the physics of what's happening. The actual event is something far more abrupt.
The correct geometric picture is much more dramatic. We'll call it the V-turn, a sharp, singular event that marks the precise moment of creation.
The key insight here is that the particle's path through spacetime isn't a smooth curve at all. Instead, it has a sharp edge, a cusp. It literally looks like the letter V. At that single point, the particle undergoes an infinite acceleration. Now, this isn't just a mathematical quirk, it's a fundamental feature of the creation event itself.
Let's be absolutely clear about what's happening here. This singularity is the geometric event of pair creation. Now, it's true that at this point, some of the elegant mathematical properties of the surface are violated. It's no longer a so-called minimal surface. But, and this is the crucial part, this does not mean the laws of physics are breaking down. The space-time surface itself remains a perfectly valid solution to the fundamental field equations. The laws of the universe are fully preserved.
Okay, with that V-turn concept now in our toolkit, let's get back to our main subject, these wormhole contact pairs that represent massive particles. We need to clarify their essential physics.
You see, the theory's field equations lay down a very strict rule. You simply cannot have an open-ended magnetic flux tube. That would be like having an isolated magnetic north pole, a monopole, and those are forbidden. So the flux must always form a closed, self-contained loop. And this is exactly why particles are modeled as pairs of wormhole contacts. It's what's needed to create a complete circuit.
Now, this brings us to a critical distinction, a point that really needs to be made precisely. We're talking about a conserved magnetic flux, that's a continuous flow through the loop. We are not talking about magnetic charge. You see, a magnetic charge would imply a source, a start or an endpoint, like a monopole. But our loop is closed. It has no beginning and no end, so its net magnetic charge is zero. What it does have is a definite conserved flow, a flux. It's this flux that's the important quantity. So now we have all the pieces on the table. We have the geometric particle, and we have the V-turn mechanism for creation. I think you can probably see where this is all going. The solution is to apply the mechanism to the geometry.
So let's picture our particle one more time. This stable, closed loop of magnetic flux, this entire three-dimensional surface just moving along, forward through time.
And here is the solution. The very same V-turn mechanism that applies to a simple particle world line also applies to this entire extended three-dimensional geometric object. The creation of the particle is the V-turn of its entire geometry in time.
So try to visualize this. A closed-loop geometry travels toward us from the future. At one specific moment, the entire structure executes a V-turn, reversing its direction in time and heading back into the future. Now, from our viewpoint, stuck on our forward-moving timeline, what do we see? We witness the seemingly spontaneous creation of two loops, a particle and its antiparticle, popping into existence right at that single point of reversal.
This elegant solution to particle creation is more than just a clever theoretical trick. It leads to a truly startling and profound implication about the very fabric of our cosmos. The mathematical underpinning for these V-turns comes from a fascinating area of mathematics dealing with something called exotic smooth structures. To put it simply, these are mathematical spaces that are perfectly smooth everywhere, except for very specific localized defects. And in this physical model, those defects are precisely the 3D vertices where particle interactions, like creation, actually take place.
And here is the stunning implication. These exotic, smooth structures, the very mathematical machinery that allows for the V-turn, and therefore for particle creation to happen at all, can only exist in a space-time of exactly 4 dimensions. Not 3, not 5, only 4. This really reframes how we think about singularities. In general relativity, they're often seen as a problem, a point where the theory breaks down. But here, they're recontextualized. What was a problem becomes a predictive strength. The singularities are not a failure of the physics, they are the physics of particle creation, a mechanism that is uniquely possible because our spacetime is 4-dimensional.
And so we're left with a final, truly profound question. If this mechanism for creating particles is correct, and if it is only possible in 4 dimensions, does this mean that the dimensionality of our universe isn't just an accident? Could it be a fundamental prerequisite for a cosmos in which matter, and therefore we, can exist at all?